Okay, so here's my penny's worth on this. Um, Going by what you got here, I understand you got the 1/4 inch and you got the 1 inch frame. So the idea here, I understand trying to keep it clean. You're not going to be able to score and bend this. First of all, the 1/4 inch doesn't like to do that, but the we only have 60-61 in stock. Even if you were to bring in 50-52, you'd be trading off the fact that the 60-61 will crumble and break, and it'll just snap in half. The 50-52 will be curved more than the 60-61. So you're going to have two problems there. Um, the main problem with this is with the table is the axis. So if you were to look at it this like think like Corel or whatever. So let's say we'll call this the x-axis, you call this the y-axis, and we'll call this the z-axis. So to get strength, you want to have as much distance ventured in multiple axes rather than just having one, which then causes the other two to have no strength and will fall. So if you're going to do this, then you could plug weld here. So you'd have to make this frame first and foremost, weld it really well all the way around here, but then this is going to bow in and this is going to bow in ever so slightly. And then in order to, so you want to have strength along this z-axis here. This is the xy. So moving that strength down here means you're vulnerable there, and you end up creating two z-axis for this whole thing to be angry about. So you'd have to then reattach closer to this z by doing plug welds, and then you could weld along here. Okay, and then you could weld here, but you still don't have any strength here. So that is a possibility, but it's not going to be super strong. And then the other way you're going to do along here is you're going to have to plug weld. You can weld along this edge, but you can do plug welds along here. All of that's great. It's just that you're going to have a lot of heat affection. This is going to probably get pulled in a little bit. You'll have heat affection up top, so, but it still won't be super strong. And even though then you kind of take care of this with a little bit of welding here, and you'll have these plug welds on the inside, even though it's 1/4 inch, it's definitely going to wobble. It's going to be, and I understand if that's fine, then that's great. So that could be a solution. The other solution is to get that z-axis as close to the z-axis as possible by removing this piece. So you could just do two straights right up against. That way you can then weld this to this and burn it along the inside to itself. And that's going to be your highest strength. And then that also gives you 1 inch worth of, or 7/8 worth of y-axis. And then again, you're just back to plug welding along the X. That's okay too, but again, this might hump up a little bit, and then you're going to have to make sure you have this just right. The other problem is when you burn this, you'll get the strength, but then this is going to pull in. So, and there's a chance that once this gets kind of all heated up, that these might not be, they'll rock back and forth a little bit. And again, you still have the, if you put your hand on this and wobble it back and forth, um, depending on, now if it's just her and it's just sitting there, so, on a continuum, you have art over here and you have a table over here. Art, the definition of art is it has no other function other than itself. And then the definition of a table is stable. And table's right in the word. So obviously you're trying to balance that. So, if this is just going to sit there and look pretty, then fine. But if people are helping her out one day and they're pulling on it or they drag it, there's a chance that this might let go. So, but anyway, that's just the way it is. If it's just going to sit there and look pretty for its life, then fine. But I don't know if it's a trade show thing or if it's going to get moved around at all, or people don't understand, and they don't, they might sit on it accidentally, whatever. I don't know how strong that'll be. But again, it's you could do it that way. Or the way I kind of was spitballing is, as usual, using our folding method. You just kind of trade some things for other things. So what you would do is do our 09 bend, do a 1 inch here, but also have legs that go down 1 inch all the way. Put our jigs on the inside, burn it. See, that gives you 4 inches here on your X, that gives you 4 inches on your Y, and then we'd also be able to burn the Z. And this is just 3 sides of our normal cabinet construction. And a cabinet of this size with a 1 inch is super strong, super strong. So we would already be starting with a good strong, and this is 90. When it comes off of here and we burn this, it's 90. So we have a good place to start. Then we can Lords the 1/4 inch to it, and then you're just basically adding this 1 inch dimension down this way. I understand it's not as clean as that, but you for sure would be a lot more rigid. And then you would be trading, and then what you could do as well is, if you want to, we can cut this on the table at a full 45. We can bevel it on the table, and then you could even inject Lords along here when you bring these pieces together, and that would give it a lot more strength as well. But that way the 1/4 inch is just looking pretty and isn't doing the work, and in here is doing the work. And then you trade off all your heat deflection, because this will be nice and cool and level. There won't be the heat deflection. We maybe add 1 cleco hole here and 1 cleco hole here on the face of this, and we trade all of the kind of, let's hope that the table's straight, let's hope the welding doesn't get all kooky, and then we have all our heat deflection, we have to bondo that and kind of sand it and make it look nice, and then plus you have the wobbly, versus knowing it's going to be more stable, but we trade it for prep time, and then they can just take their time to make all this go away. We could even, Lords these shut when we're done and sand them flat on both sides. You will have the little bit of welding on the inside of the jig there, but that would be no different than, welding on the inside here. I don't think anyone's going to see it. So either way, you could do it the way you have it, or you could do it this way. But then, like I say, we're just trading a more known and possibly more stable for just having to kind of spend a little more prep work to make it look good. You will see, like if you imagine this in a 3D, you'll have this way, and you'll have this on over here. You have a 1 inch, and you'll just have your score mark and bend, but if that's no big deal. But anyway, it'll come together possibly a lot more just knowing what we're going to have, and then just dealing with making seams go away. Or you could make this part go long, have this part be flush, and then just deal with the seam on the side. Again, just spend the time to kind of museum bondo this and make it look really nice, as opposed to, here it would also look nice, but you're going to have your, how the heat's going to affect this. This could be bent a little bit, or, this could bow up, or however. Also just making sure your table, the skill of the welder, skill of the table, or, how that's all going to turn out. So, but this could be one way. It could be this way. So either way, that's how I see it.